I'm going to go ahead and go through another life table in its entirety, utilizing just the generations and the number alive during each generation. Later on, I'm going to be adding these features to it, which is our age-specific mortality rate and our age-specific mortality. So if you already understand how this works, you can go ahead and skip ahead to where I start working through these. But let's think about survivorship here. So survivorship in the first generation, or the 0th generation if you prefer, is always going to be equal to 1. Because it is the number you have alive left divided by the number that you started with. So let's see what our survivorship for generation 1 is going to be. And that is, again, the number you have alive divided by the number that you started with. So 159 divided by 530 gives us 0.3. So how then do we calculate survivorship for generation 2? Well, it's the number we have alive divided by the number we started with, which is 80 divided by 530, which gets us to something like 0.15. Working right along, feel free to pause it, see if you can figure out what these are before I solve them for you. 48 divided by 530, 0.09. 21 divided by 530, this is a survivorship of 0.04, something like that. 5 divided by 530, 0.001. Very, very low. So again, this is just a number that are surviving on to the next generation. The next thing I'd like to talk about is D of X, which is the age-specific mortality. Age-specific mortality just tells you how many individuals are dying between these generations. So in this case, if we were trying to figure out our age-specific mortality, how many died in generation 0, we take this number and subtract this number. So if you want to be mathy with it, which you probably don't, but that's okay, we'll do it anyway, you're going to take n sub x minus n of x plus 1. I think it's a bit easier to just have a sort of intuitive, more understanding. And basically, you're just going to take how many were alive in the previous generation and subtract how many are alive in the next generation. This tells us that 371 individuals died between here and here. So I just took 530 and subtracted 159. So let's calculate our age-specific mortality for generation 1. So how many died between here and here? Well, 159 minus 80. We had 79 died. And again, this hopefully makes a little bit of sense. If you have 80 individuals left in generation 2, and in generation 1 you started with 159, that means that 79 died. So let's calculate it for generation 2. We're going to take this number 80 and subtract 48, which gives us an age-specific mortality of 32. 32 individuals died between here and here. Next, we're going to take 48 and subtract 21, which gives us a 27. That tells us that 27 individuals died between generation 3 and generation 4, or between time period 3 and time period 4. Okay, that's how we get from 80 to 21 as we subtract 27. So let's see how many died between generation 4 and generation 5. The answer to that is 16, and we didn't include another segment on our life table, but in generation 6 we wind up with 0 individuals, which means that 5 died, and our survivorship is 0, by the way. So those are our age-specific mortalities. Now we can convert these age-specific mortalities into an age-specific mortality rate. And the way we're going to do that is we're going to take D of X and divide it by N of X. So 370 divided by 530 in this case gets us an age-specific mortality rate of about 0.7. which is a lot. That means that 70% of the individuals that we started this generation with have died. So again, you take d of x, which is 371, the number that died, and divide it by the number that you started with. So how are we going to do that for generation 1? What numbers are involved here? So again, how many individuals died out of the number that we had? Well, that's 79 divided by 159, which basically gives us 0.5. Half of the individuals that were alive in generation 1 died before generation 2. Let's continue on. How many died in generation 2? It was 32. How many did we start with? That was 80. 32 divided by 80 gets us a 40% age-specific mortality rate. 40% of the organisms that were alive died between generation 1 and generation 2. Let's continue on. We're going to take 27 and divide it by 48. 0.56. We're going to take 16 and divide it by 21. Times divided by 21. 0.76 or thereabouts. We're going to take 5 and divide it by 5, which gives us an age-specific mortality rate of 1. None of these, I think they're ground squirrels, survived past the 5th generation, the 5th year, the 5th time point. And so this information, or this chart gives you some information about kind of what it's like to be a squirrel. It's very, very dangerous early in life. Then you have a few years where it's your mortality rate is less, 0.5, 0.4, and 0.56. It's lower during sort of middle adulthood here, and then it starts to get very dangerous again as you get older. 76% age-specific mortality rate and a 100% age-specific mortality rate for our 5th generation down there. Okay, hopefully that was helpful. So again, what we just did is we completed our life table just using these first 2 columns. Okay, we use that to calculate our survivorship, or the proportion of individuals that are surviving through subsequent generations. We used it to figure out our age-specific mortality, the number of organisms that died in a given generation. And we also calculated our age-specific mortality rate, or Q of x, which is the proportion of individuals that died in a given generation. So here, 70% of our squirrels died between generation 0 and 1. 50% of our squirrels died between 1 and 2. 40% of our squirrels died between 2 and 3. Okay, so again, these are age specific. So it makes sense that these don't add to 1. If you don't understand what I mean by that, don't worry about it necessarily. But there you go. This is a more completed life table. And again, there are more things that we can potentially put on there, but those are for later on.